Okay, so this video is just going to be some general information about functions to get you ready for next chapter. Okay, the first thing we're going to talk about is function notation. So right now, all the equations you guys have seen, linear equations, quadratics, anything, have always been y equals 2x plus 1. So what function notation is basically we're going to write something besides y, but it means the same thing. And what it is f of x. So this is exactly the same thing, and this is read f of x. And what that tells us is this is a function with the input variable of x. This means the exact same thing as up here. So like if I made an xy chart, I can now make an f of x chart. Okay, so don't get confused. Over here, if you remember, y equals the square root of x is not a function. So I'm not going to use function notation. I'm not going to use f of x. That f of x tells me it is a function. I don't have to worry about it. This is just a relation at this point, okay? Now, this is a function, y equals x squared. So again, this time, I'm going to do g of x. It doesn't mean anything. It's just I'm using the letter g because I've already used the letter f over here for f of x. So the ones you see the most common are f of x, g of x, h of x is another one you'll see. All of these are functions. This means the same thing as y equals 2x plus 1, y equals x plus 1, and y equals x squared. So don't freak out about seeing them. That's all it means. Now, you may see something like, okay, f of x is equal to 2x plus 1, which means the same thing as y equals 2x plus 1. And you may be told you need to evaluate f of 3. Okay? What this means is we've replaced the x with the 3. They just want you to plug 3 in for x. So f of 3 means they want you to replace the x with 3. I wrote that weird. So 2 times 3 is 6. 6 plus 1 is 7. So f of 3 is 7. This would be no different than saying find y when x is 3. They just want you to plug in and find what y is. So that's all that is. The next thing then, with functions in general, is the vertical line test. So far, the only way you guys have been able to determine if something is a function is really to think about that function machine. And, you know, for every input, is there one output? Okay, and that's still kind of what you're going to have to do for equations and tables. However, for graphs, we really don't need this concept anymore. You can do something called the vertical line test. So if I have a linear function here, a line, if I draw a bunch of vertical lines through it, if each vertical line touches it in only one spot, it is a function, because that's telling me that there's one output. That says for every input, there's one output. So the vertical lines are representing that. If I have a graph like this, and I go to draw vertical lines, okay, here those vertical lines are not touching my graph at all. That's not 1, that's 0 output. So that means it's not a function. And here it's touching my graph twice. So if it touches your graph more than once, that is not a function. So that's all the vertical line test is. You draw vertical lines through it. If every vertical line touches it once, it is a function. If it touches 0 times or more than once, 2, 3, 4 times, it is not a function. So that makes it a little easier to look at a graph and determine if it is a function or not. And then the last thing with our in general of functions is what we call domain and range. Okay, pretty simple. Domain is all your possible x values. In other words, your inputs. So when we're talking functions, your inputs. What are we going to put into the machine? That's your domain. Range then is all your possible x values. I mean y values. So in other words, your outputs. Okay, and this is why we were talking about sets, because a lot of times we're going to talk about domain and range as sets. So to give you an example, if I give you a table of values. Okay, domain is the x values. So for this, all we know is what's in the table. So we're going to use raster form here, and we're going to say the domain are just the numbers, and I'm just going to list them. We use the little bracket things because we're going to write it as a set. Range, then, is just my y values. And that's it. That's all you have to do. Okay? If this was a horizontal line where all of these numbers are going to be the same, this would still be my domain, and for my range, I don't need to list 5s that many times. I can just say it's only a 5. So that's how domain and range works in terms of listing. If I'm looking at a graph though, so if I'm looking at a line, this line goes forever, which means there are infinitely many x values and there's infinitely many y values. So we're going to have to write this in set builder notation. Our domain, our x values. Can our x values be any number? Yeah, they can be positive, they can be negative, it can be a fraction, it can be a decimal. So our domain is all reals, and that's the symbol for all reals. That's all you have to say. It's all real numbers. Okay? You could, if you wanted to do it, x such that x is all reals, but I would accept that. Same thing with range. There's no limit on what y can be. Y can be negative, y can be positive, it can be fractions, it can be decimals. So that is going to be all reals as well. Another example, I look at this graph, which is the equation y equals x squared. Okay. If I look at my domain, again, I'm looking at the x values. This is on the positive and negative side. I can have fractions, I can have decimals. So again, my domain is going to be all reals. Range, however, is going to be different. If you look, this graph never goes into the negatives. It starts at 0 and goes up. And you guys know if you square a number, positive numbers will be positive, negative numbers will be negative. I can, however, have fractions and decimals. So there's a couple ways you can say this. Y such that y is greater than or equal to 0. Okay, and that's saying that it's all reals. It has to be greater than or equal to 0. Another way you can say it is all non-negative reals, because that's the same thing as greater than or equal to 0. This is probably the easier way. Okay, so that is domain and range.